sandwich types. Okay, let's go on to the counting principle then. Now the counting principle is nice because instead of having to sit there and make a tree diagram for something that could potentially be very large, we're just making a very simple figure here of what the actual number of possibilities are. It doesn't list the possibilities, which is a big con. If they ask you to list the possibilities, you're going to have to go with the tree diagram. But if they just want to know a number, then we can use the counting principle. With the counting principle, all you're really going to do is multiply together each number of choices for each level. And that'll give you the same type of numerical answer that we came up with 1 and 2. So example 3 says to build a skateboard, you can choose from 3 board styles, 2 wheel types, and 8 paint jobs. How many different looks are possible? To build a skateboard, you can choose from 3 board styles, 2 wheel types, and 8 paint jobs. How many different looks are possible? So the first level, you're choosing from the 3 board styles. Second level, you're choosing from the 2 wheel types. And the final level, you're choosing from the 8 different paint jobs. So you're multiplying together 3, 2, and 8, and that's, of course, 48. So there are 48 total different types of skateboards you can get from that combination. Okay, example 4. You are creating a 3-character password with 2 numbers, 0 to 9, and any letter. What is the total number of possible passwords? You are creating a 3-character password with 2 numbers, 0 to 9, and any letter. What's the total number of possible passwords? Okay, so in the first spot goes a number from 0 to 9. So how many different options is that truly? Kaylee?
9.
Nope.
10.
That's 10 options. 0 to 9 is actually 10 different numbers. Now in the second spot can go on any number from 0 to 9 as well. It doesn't say anything about not repeating, so there's 10 options there. In the last spot goes a letter. And how many different letters do we have?
26.
26. So we're doing 10 times 10 times 26, and that means there are 2,600 different passwords I can come up with just 3 characters. Okay, let's try some real possibilities here, real probabilities. The Indiana lottery. In the Indiana lottery, there are balls numbered 1 to 48 in a hopper, and there are 6 picks that have to be made. Indiana lottery, there are balls numbered 1 to 48 in a hopper, and there are 6 picks that have to be made. Okay, so we've got 6 picks. Alright, so for the first drawing here, I'm picking from all the numbers from 1 to 48, which is how many different options? 48. Now, in the lottery, when they take a number out, it's gone for the rest of the drawing. So if I've taken one out, how many are left for the next number?
47.
47. And that process is going to continue all the way down. So the next one, of course, there'd be 46 then 45, then 44, and finally 43. So we multiply that together, and for that result is 8,835,488,640. And of course, there's only one set of numbers that ever works. So that means you've got a 1 in 8 billion chance of winning the Indiana lottery. You have a better chance of being bitten by a shark and hit by lightning.
Well, you could just swim out in the ocean and get bit by a shark.
Alright, Powerball. Now, Powerball chooses from 6 numbers too. From there, they choose a white powered ball numbered 1 to 55 for the first 5 picks. Then for the last pick, they choose a red Powerball with the numbers 1 to 42. Okay, so start with the white Powerball. So I'm choosing from 1 to 55. That's how many options? 55. Now, same thing here. Once a number's picked, it doesn't come back in. So for the next spot, I would have 4. Then it's going to go 53. Then 52. Then 51. Now, once they get to here, now they switch to the red Powerballs. They're choosing from numbers 1 to 42. So that, of course, means they have 42 options. And if you multiply this together, you get 17,532,955,440. Yeah, not good odds.